Well, you can easily think about it this way. Let's define a rigid body as just a collection of points whose relative positions to each other can't change. And for the mathematicians in the audience, we're going to pretend that's a well-defined statement, okay? Or you can think of it as a box. So the first thing I can do is I can locate that box in 3D. I can take one point of that box, say the corner here, and figure out the x, y, and z location of that box. So that's 3 degrees of freedom. Then I can take some other point on that box, let's say the corner, and I can move it around. Now I can't change its location in space arbitrarily because I'm holding this point fixed. So essentially this corner can move around on the sphere. So this point here can be moved around anywhere on the sphere. So this is supposed to be like rotated backwards this way. All right? And just the way you can think of on a globe from the middle, there's a latitude and longitude to get any location. There's 2 degrees of freedom of a vector's direction. So that's another 2 degrees of freedom. So we're up to 5. And finally, once I have this vector specified, I can rotate, I can spin about that vector. So the cube here, as indicated by this fancy Microsoft PowerPoint arrow that's in here, we can rotate it about that diagonal. So that's 1 more degree of freedom. So that's why there are 6 degrees of freedom for a rigid body. I'm going to assume most of you knew that already, but there you go. That's why there's a fast forward button.